Hey guys, welcome to Guys Teach Stuff.
Today we'll be covering 7KE, balanced and unbalanced forces, as well as safety standards. So what is a balanced force exactly? So what a balanced force essentially is when two forces which are acting against each other are equal, right? And unbalanced forces are when two forces which are acting against each other are not equal. If two forces acting on an object are balanced, if the object is stationary, it will remain stationary. However, if it is already moving, it will remain at a constant speed. However, if the forces are unbalanced, if they are acting on a stationary object, the object will begin to move. But then, if it's acting on a moving object, it will start to change its speed. Utilizing this sort of concept of balanced forces, we can understand and explain how a force meter works. When we stretch a spring with a weight, it gets harder and harder to pull it because the spring sort of pulls back on the weight until eventually the weight becomes stable and remains still. So the force meter shows the weight of the object. There's also a similar explanation as to why you just don't fall through the floor or don't fall through chairs. It's because of the fact that although very minuscule, the shape of the object changes slightly and pushes back up at you. Now I'll be talking about the second part of 7KE, safety standards. So in many sports, people rely on ropes, equipment, a bunch of other stuff to keep them safe. And as you can imagine, all this equipment needs to be able to do certain things and meet certain standards to make sure that it is strong enough for its purpose and safe to use. Let's say in climbing, the ropes are tested for strength and for stretchiness, because the more stretchy the rope, the smaller the impact force on the climber when the rope stops them from falling. There are no set standards, however, on how much friction the outside of a rope must provide. However, most manufacturers will test their equipment for friction as well as for stretch to make sure that customers are happy and will continue to buy from them. Alright, so since this video was pretty short and it was just one topic, I'd actually like to take the liberty of going into more detail and actually extending into a little bit of GCSE, but I think it'll be pretty interesting. So there's actually a way to figure out how much an unbalanced force will accelerate an object. So the way you figure this out is with this certain equation called F equals ma. Force equals mass times acceleration. This is actually called Newton's second law of motion. By the way, the thing that I described to you earlier about balanced forces and unbalanced forces affecting objects in a certain way, that was Newton's first law of motion. So basically what the equation says is that for a certain amount of mass and acceleration, you will need X amount of force. Just, if you think about it intuitively, it makes sense, because the heavier an object is, the more force you're going to need to accelerate it, right? And the more you want to accelerate an object, the more force you're going to need. And so, force equals mass times acceleration. So in this particular equation, force is measured in newtons, mass is measured in kilograms, and acceleration is measured in meters per second squared. That per second squared is a bit weird, and I can say that for another video if you guys want. Now, of course, you can rearrange this equation any way you like to find mass from force and acceleration, force from mass and acceleration, or acceleration from force and mass. For example, if I want to find acceleration, if I have the force and mass, it ends up being acceleration equals force divided by mass. So I'll give you an example. If an object weighs 2 kilograms and I want to accelerate it by 15 meters per second squared, how much force am I going to need? So force equals mass times acceleration, so that means the amount of force I'm going to need in newtons is 2 times 50, so I'm going to need 100 newtons. Now I'm going to give you guys an example to solve for yourselves, and this one's going to be a little challenging because, hint hint, you're going to need to rearrange the equation. So if I apply 30 newtons of force on a particular mass and it accelerates by 6 meters per second squared, how heavy is the mass? I'll give you a second to think about it. Pause the video if you like. So here's the solution. I hope you got 5. Because what you're going to have to do is you're going to have to rearrange it so that mass becomes force over acceleration, and then from there it's pretty straightforward. You substitute the numbers in. Force is 30, acceleration is 6, 30 divided by 6 is 5. So that's how you get the answer.
And that, my friends, is how you utilize Newton's second law. Don't worry, this won't come up in your year 7 tests. I'm just telling you guys this in case you're interested.
So, in conclusion, today we learn how to identify balanced and unbalanced forces and explain the effects of balanced and unbalanced forces. Thanks for listening, everybody. Go watch our other videos about biology and chemistry. Look out for some upcoming videos about the practicals of 7K that I'll soon be covering. And have a great day, everybody.